So while I'm just doing some paperwork here and I'm being loaded, just wanted to talk about, we've seen the High Wire Balancing Act, yeah, and it seems very impressive. And you see the guys up there, what they're doing is impressive and very nerve-wracking, I shouldn't wonder. It's not something that I would be able to do. However, it's not as difficult as it looks because it's self-balancing. So long as they can keep their feet from slipping off of the cable, it's self-balancing. Right, let me explain the physics of what's going on here. The bar, you notice they're holding a bar and they're usually holding it down quite low. And the bar isn't just a straight bar, it's a bar that it bows. Yeah, so that action of bowing, the ends are lower where the pivot point is. You're on the cable, you're stood on the cable. The ends of that bar that they're holding will droop down, and it will droop down. If you notice, it will be lower than the pivot point of the cable, i.e. lower than where their feet are. That's the pivot point, okay? Provided that it's doing that, they can never lose their balance. They can never tip off one side, because the laws of physics will dictate that the mass is at its lowest possible level, and if you put it out of balance, it will just move it back to balance again. That's gravity pulling on it, so it's all pulling in one direction at the same rate. So that's why it will balance, yeah. That's why water balances. This is why everything balances like that. If you just say, for instance, you remember Weebles, same thing going on in a Weeble, yeah. You got the weight at the bottom, so most of the mass is at the bottom, and it's flat at the top, curved at the bottom. So the mass itself is flat at the top. It's curved, so when you push it, a part of the mass has moved above the pivot line, and it goes, no, we don't want to do that, and it goes back down to the pivot line again. And that's how come they stand back up. You may well have seen desktop, the little desktop thing. It's like a little paperweight, and then on top of that it's like a little acrobat holding the bar. If you notice the bar, and it's got two little weights on here, and that's extra weight it's adding just to make it like it, so it can't go wrong. So it definitely guarantees it that it's above a certain mass below the pivot point. So you ever notice, then you tap it and it can rock backwards and forwards, but it never falls off, and it's basically just stood on a point, almost on a point. Yeah, it's like a little concave bit, but it's a point inside of a little bit, and it will never fall off. It will never rock over. It won't do it. It just won't. And that's the laws of physics at work. Okay, so there you go. Just thought I'd lob that in. I got to get this paperwork done before I get loaded. Right, adios.